Okay, my dear people, we are at the summit of Chapter 4 with story problems. And remember, our goal here is to create two equations from the information given in these story problems. And that's what we want to do. Once we get the two equations in place, we can then solve using our methods of choice, substitution method or the addition method, etc., etc. All right, so let's start with number 13. These problems come from our textbook, and it looks like it's page 318 from the text, but let's concentrate on the problem at hand. All right, so we've got our derivation of the two equations. So I've got a first number plus twice a second number is 18. Well, so we could call the first number x plus twice a second number, and let's call the second number y. A first number plus twice a second number is 8. All right, easy enough. Twice the first number plus the second totals 25. Find the numbers. All right, here's our second equation here. Twice the first number, well, our first number is x, so twice that, plus the second number, and the second number is y, totals 25. Okay, there's our second equation. And then we just solve for the variables x and y. Find the numbers. All right, so what method do you want to use? What's your choice? So, well, if I'm doing this, I guess I'll multiply the top equation here by -2. And then I'm doing the addition method. So I got -2 times x is -2x. Oh, I don't want that line yet. -2 times x is -2x. -2 times 2y is -4y. And that's going to equal -2 times 8, which is -16. Okay, now I'm going to have 0. Y minus 4 is -3y. And that's going to equal 25 minus 16, which is 9. So it looks like y equals -3. All right. So if y equals -3, I'll plug into the second equation here and figure out what x is. So I'm going to have 2x plus -3, I guess I can do that, or -3, equals the 25. I'm going to solve for x, so I'll add 3 to both sides. X equals 14. And there's my solution set of 14, comma -3. All right, so there's our first taste of a story problem, number 13. Next up, all right, number 17. And this is the case. Now, when we have story problems, the first one wasn't so meaty, but this one is. So I'm going to read it, reread it, until you understand what's going on. Anne Marie Jones has been pricing Amtrak train fares for a group trip to New York. All right, going on a trip. 3 adults and 4 children must pay $59. 2 adults and 3 children must pay $112. Find the price of an adult's ticket and find the price of a child's ticket. Alright, kind of got that idea there. So I'm looking for the two equations. And the first one comes from, well, this first sentence is really kind of meaningless. It's just describing what they're going to do. So those words we can get rid of. Here I've got 3 adults and 4 children must pay $159. So how about 3, I'll use A for the variable, adults, plus 4 children equals $159 or 159. There's our first equation. The second equation is going to come from here. 2 adults and 3 children must pay $112. 2 adults plus 3 children, they have a cost of $112. And this again is our system. They're not being very kind to us, I can see, because we've got these numbers that aren't multiples of each other, where we have to do it twice, right? I have to multiply the top by a number and the bottom equation by a number. So in this case here, I'm going to pick on the A's to be opposite of each other. So I'm going to multiply the top by 2, the bottom by 3, but then one of these numbers has to be negative. And I'm going to pick the bottom one to be negative. Do I want the bottom one to be negative? No, I'll pick the top one to be negative. Doesn't matter though. Okay. I'll rewrite this problem to be negative 6a minus 8c, and that's going to equal what? Let's see, I've got 2 times 159, is that 68? 368, I got 8, carry the 1, 10, 11, 10, 11, carry the 1, 2 times 1 is 2 plus 1 is 3, 18. That sounds right, and that would be negative. Alright, then I'm going to do the same thing here with the bottom equation of 3 times 2a is 6a, positive 6a. 3 times 3 is 9, positive 9c. That equals 3 times 112, which is 336. Okay, so here's my new system. Rigged it up so the A's cancel out. Negative 8c plus 9c is c. So one child's ticket is 18. Okay, if one child's ticket is 18, what is the adult's? So I'll go back down and I'll use this equation here to figure out what the adult's is. So here I've got 2a plus 3 times c, and c is 18, equals this 112. Okay. Let's see here. 3 times 18 is 30, and 24, 54. So I'm going to subtract 54 from both sides. And I've got 2a that equals, what's this? 8, 5, 2a equals 58. I'm going to divide both of these sides by 2. So the adult's ticket is, what's half of 58? 29. So the adult's ticket is 29. So A equals 29. Okay, and these are the costs for the adult's ticket and the child's ticket. Okay, that was number 17. Number 19, Johnston and Betsy Waring have a jar containing 80 coins, all of which are either quarters or nickels. The total value of the coins is $14.60. How many of each type of coin do they have? All right, so we've got a special setup here for this problem. They have a jar containing 80 coins, of all of which are quarters or nickels. So what's the units? Number of units do they have? So I could write this first equation as the number of quarters, Q, plus the number of nickels, N, have a total of 80. The number of the coins. The second equation is going to be related to the value of a quarter and the value of a nickel that equals the value of the coins that's in the jar. All right, so we know that to be $14.60. And this left side, I'm going to write it as the quarters is they're worth a quarter, or they're worth 0.25. So that would be 0.25 Qs. That tells us how many quarters times 0.25, plus the nickels, which is 0.05 N, the value of a nickel. Okay. So I can use what I have here and use my calculator with the decimals, or I can multiply everything by 100 and move the decimals over 2 places to the right, and therefore using, what shall we say, whole numbers. So I could rewrite this to be, I could rewrite this bottom one if I chose to. I'll do it. You know, we didn't do this in class, but maybe make it a little bit easier. I don't know. So this is going to be 25Q plus 5N equals 1,460. Okay, and now I can use the top equation, the bottom one, and not use this one in the middle. Okay, so I can basically eliminate that. If I eliminate it, I can cross it off like so. And then here's my system, the top and the bottom. And I think I'll multiply this top equation by, what do you think? It doesn't matter. I'm going to multiply it by -5. I want the n's to go away. And let's see what happens. If I multiply it by -5, then I'm going to have -5Q minus 5N. That equals -5 times 80, which is -400. So I've got 20Q, nickels are gone, that equals this, 1060. Okay, divide both sides by 20, so that would mean Q equals 1060 divided by 20. Right? So zeros cancel out. I'll do this manually. Equals 53. Okay. So that means I have 53 quarters. And how many nickels will that mean I have? So that means I'll plug it into this equation here, bringing this down here to be 53 plus N equals 80. Then I simply subtract the 53. That means I have 27 nickels. So N equals 27 nickels. Okay, you plug that in, 53 quarters, 27 nickels, and it'll total $14.60. Okay, so there's our answers here. Next. All right, number 45. I've got the traffic signs are regulated by the manual on uniform traffic control devices. According to this manual, if the sign below is placed on a freeway, its perimeter must be 144 inches. Also, its length must be 12 inches longer than its width. Find the dimensions of this sign. All right, so let's see. Read it once, read it again, if need be. And I do pick up on a word perimeter here. And when I see this in a story problem, I think of the perimeter formula of 2L plus 2W that equals the perimeter, P. And the P is 144 inches, where the perimeter must be 144 inches. Okay, so this I know to be true. That's all it says up to here. This is also its length must be 12 inches longer than its width. Okay, this part here, its length. So that means its length must be, I could use them as is, must be, the length is, or must be, 12 inches longer than its width. So it would be the width plus 12. And that's my second equation. It's kind of hidden in there when we're reading it. We were looking for something other than that type of a statement, but many times in perimeter problems they use that type of language for the second equation. We have to pick up on it. Oh, the length is, and then you know how that goes with inches longer than the width, or inches longer than the height, or whatever the case may be. Nevertheless, we've got our two equations here, and this time I'm going to choose the method of substitution. If L equals this, we can go back and substitute it for the L in the perimeter problem. So in other words, this is going to be 2 times L, but L is W plus 12 plus 2W, that equals this 144. All right, let's clean it up here on the left side. I've got 2W plus 24 plus 2W okay, how about 4W okay, let's raise this up a little bit. I'm going to subtract 24. And 4W equals 120. Divide both sides by 4. And the width equals 120 divided by 4 is 30. What is that? 30 inches. All right, the width is 30. What is the length? And I'll use this nice equation over here to figure that one out because it's much easier. So the length equals 30 plus 12. And the length therefore equals 42. These are all in inches. So that's it. Length, width is 30. There you go. Next problem. All right, here's the last one. Last problem we're going to do. And it's a meaty one, that's for sure. So keep your wits about you, and we'll get through this without a problem. Twice last month, Judy Carter rented a car from Enterprise in Fresno, California, and traveled around the Southwest on business. Enterprise rents his car for a daily fee, plus an additional charge per mile driven. Judy recalls that her first trip lasted 4 days. She drove 450 miles, and the rental cost her $240.50. On her second business trip, she drove the same level of a car 200 miles in 3 days and paid $146 for the rental. Find the daily fee and the mileage charge. Okay. We had something similar to this in one of our story problems from a different chapter. I don't recall which one it is. But it was about a car rental. And a car rental has it, we want to set up the equation. So if we have a daily fee, that's our constant. That could be witnessed as our constant, depending on how many days then you take the car for. So let's see, I could say in this first equation that Enterprise rents this car for a daily fee plus an additional charge for per mile driven. So we could have a daily fee, let's call it F for fee, daily fee, plus mileage for the per mile driven. So there's a charge for per mile driven, depending on how many miles you drive. So we could say there's a charge, let's call it C, charge for that, depending on the number of miles driven. Okay, and what else do we know here? Judy recalls that her first trip lasted 4 days, and she drove 450 miles, and the rental cost her $240.50. So we know that this cost her $240.50. Okay, and then we're going to go back and break this down and fill these in wherever we can. Remember, I've got 3 variables basically here, but we have to have 2 of these 3 variables filled in, or we won't be able to solve the problem. Okay, so here for this first day then, for her daily fee plus an initial charge per mile driven. Julie recalls that her first trip lasted 4 days. All right, so I'm going to put a 4 in front of this F. We don't know what the daily fee is here, but it did last 4 days. And the she drove 450 miles. Her first trip lasted 4 days. She drove 450 miles. So here I can put 450. On her, okay, so there's our system basically. Remember, we're doing a system of equation. I guess I misspoke earlier. I'm not going to have the 3 out of the 4. We're solving 2 variables here by the system of equations because we're able to eliminate one. Okay, so then I'm going to rewrite this to be 4F plus, what can I call this? 450 C, that's the charge for the mileage, equals $240.50. All right, so there's our first equation. Let's see, on her second business trip, she drove the same level of car 200 miles in 3 days and paid $146 for the rental. All right, we know it's $146 for the rental for 3 days. So that's going to be 3F. I made up these letters now as for variables. You can make up your own. You may want to put days here instead of F for the fee. 3F plus 200 miles. And there's a mileage charge. Nevertheless, this is the system. Okay? And again, this is what we got to solve for. So again, I got this problem here. I don't have multiples of each other. So that means I've got to do that little extra work here, which would be multiply the top by, I'm going to pick on the F's again, multiply the top by 3 and the bottom by 4, and one of them has to be negative. Okay, which one shall be negative? I'll take the 4. Shall I take the 4? Doesn't matter. I'll take this positive and this negative, because I got to rewrite them anyway. I keep thinking I'm going to write it underneath it, but I'm not. I got to rewrite the whole things, both of them. So anyway, here I'm going to have what? Negative 12F minus 3 times 450, which is 1350. C equals negative 3 times 240 is negative 721. 50. Okay. The next line here, it's going to be positive 12F. And then that's going to be plus 4 times 200 is 800. C. That equals 4 times 146 is 584. And this is the system. Rewritten, so I got opposite F's here, so that's 0. This is going to end up being 550 negative. 550C. That equals this, which is negative 137.50. What is happening here? Okay. Do that like that. There we are. So divide both sides by this negative 550. And the charge per mile is a quarter. 25 cents a mile. And next we're going to plug in to figure out what is the daily charge. What is the daily fee, F? So I can go back to our original here, one of our originals here. I'll take the bottom one here, this 3F plus 200C. A little easier to work with that way. And I know that it's going to be 3F plus 200 times 0.25, which equals 146. Okay. 200 times 0.25 is 50. And I'll subtract 50 from both sides. Giving me 3F, that equals 96. Divide both sides by 3. And the daily fee, F, equals 32. And that's it. There they are, folks. 5 problems we'll have on our exam Not all 5. I don't know. I'll pick up 2 or 3 or 4. I don't know. I'll figure it out. Anyway, that's it for this section 4.4. Bye.